Okay, here's one of the first examples that kind of puts everything together here. So kind of putting all the pieces together, and let's have at it. So the first thing that we want to do is that we want to find our amplitude of the function. Now remember, the amplitude is that we take this value right here, take the absolute value of it. Okay, so the amplitude is going to be the absolute value of 1.5, which is going to give us 1.5. Okay, so in this case, I like to just mark off that the function is going to have an amplitude of 1.5, which means is that it's going to go 1.5 north and 1.5 south as the sine function goes ahead and develops. Okay, but I'm not going to do a sine function. I'm not going to trace it out right now. I'm going to wait until I get the period here, and to kind of box off and see what's going on with this particular function. You'll see what I mean in a moment. Okay, so the period, as the videos past have said, is that the period is going to be 2 pi divided by this number right here, which is going to be 2, which means pi. Okay, so that means is that the entire sine function is going to go ahead and get her done in pi units. And so if I go like this, and if I imagine a box, if you will, that is going to capture the sine wave in its first kind of like before it repeats itself, this is what it's going to look like, okay? And we want to separate that into 4 distinct sections, okay? So I put something right in the middle there, and then the sine wave, like we talked about before, is going to go ahead and have these kind of like 4 distinct pieces that are going to define it. And I'm going to just put this in this purple color here. So it's going to go up, okay, up here, and then down, oops, and then down, and then up, okay? So the sine function itself, and I'm just going to do this little dotted line here, is going to look like this with the adjusted period and amplitude. So the amplitude is 1.5, the period is going to be pi. So now what we need to do is that we need to account for the phase shift, which is going to make this kind of like cutout go from the right or to the left some, and move it around a bit, okay? So let's see how that's going to work out. So the phase shift is going to be over here, and what we do is that it's going to be C over B, okay, where this is going to be C and this is B, and we're going to move in the opposite direction of that sign, okay? It's negative, so we're going to be moving right. So the whole thing is going to be moving to the right. So that said, I get pi over 3 divided by 2, which is going to give me pi over 6. And I know that that's going to be moving to the right. So, for just kind of like, I know that you guys can't do this at home, but you can look and see that this entire thing is going to be moving pi over 6 to the right and then continue with that particular pattern. I'm going to do it out, just kind of like longhand here, and then continue the pattern and see where this goes. So pi over 6, that means is that all of these points are going to go here, and pi over 6, you can see that that distance right here is 1, and so I'm going to continue, or 1 grid mark, I should say. So I'm going to continue that grid mark on over in this direction for each one, okay, like this guy and this guy over here, okay, and this is going to be the phase shifted sine wave. Now, what I'm going to do is that I'm going to continue the pattern. When I say continue the pattern, you're kind of looking at, well, how does the rest of the sine wave go? And you can see that from here to here, that's like going over 1.5 grid marks and up 1, 2, 3. So I'm going to do that 1.5 grid marks and then go up 1, 2, 3, over 1.5 grid marks and then go down, over 1.5 grid marks and then down again, and in this way 1.5 grid marks and go up. And I'm just trying to go ahead and complete the process here so our sine wave looks good. And I'm going to do the same here real quick, and just kind of, like I said, complete the process so we have a really good example to go back to. So it looks like that red graph right there, there's a phase shift of the pi over 6, and we're going to the right that much. We look pretty good, okay? And from the vertical shift, we don't have anything right here moving that graph up or down any. So the vertical shift, we don't have anything going on, okay? Now, here's one of the trickier parts of completing the whole process with the sine graph, is that we want to make sure that we can find all the x-intercepts. And again, if we look, x-intercept, 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 and the whole thing goes on. Well, we don't have time to list an infinite amount, so we're going to make an equation that is going to define those x-intercepts, any one that we can get. And the way that we do that is that, this is what I tell the students to do, okay, is that we take the first x-intercept, positive x-intercept, it's a quality of life thing, I know that you guys laugh at me for saying that, but it's true, which is going to be pi over 6. And you add, okay, 1/2 of the period, which is going to be pi, okay, so that's pi over 2, n, where n is an integer. And remember, an integer are all whole numbers and they're opposites. So that basically means positive 1, negative 1, positive 2, negative 2, positive 3, blah, blah, blah. You guys get it, okay? And so that means is that if I were to, and just follow the graph as, if I were to start here, okay, I know that that would be pi over 6. And if n equals 0, okay, so let's take a look. If n equals 0, which is an integer, then I know that the first x-intercept would be pi over 6, which is already highlighted. Now, if I look at the second highlight, which I'm going to do here in blue, okay, is that I want to skip to the next x-intercept, and that's going to be pi over 6 plus half of the period. So that next integer is going to be 1, and so I would have that, and when I add these guys together, it looks like I'm going to get 2/3 pi, okay? And et cetera, if I were to, and just doing this one out in orange, if I wanted to add another integer, so we kind of have, and I want to make sure that you guys know, kind of like this point that we start off at, which is going to be pi over 6, and its distance from that particular starting x-intercept is what we're trying to go ahead and calculate out, okay? So this one is the first guy right here. This guy is the second one over here, and now we're at, what did I do there? There was orange, okay, over here. So I would have pi over 6 plus pi, which is going to give me, let me do this out. I believe it's going to be 7 pi over 6, which is the value of that guy right there, okay, and so forth. So the way that we write this is going to be pi over 6 plus pi over 2 n, where n is an integer, comma, 0, okay? And so that is going to, any x-intercept that we want to find, that's going to be it, okay? All right. Okay, so next thing we need to do is the y-intercept, okay? And so for the y-intercept, we're going to have to use our knowledge of the trig ratios. So I hope you're ready. So we go, we're going to let x equal 0, of course. So that ends up with f of 0 equals 1.5 sine, did I do that right? No, I don't want that, that guy there, sine of 2 times 0 minus pi over 3, and I think that's it, yeah. And so what we're going to do is that, just kind of cleaning this stuff up, we end up with 1.5 sine of, let's see, this is going to cancel out, and so I end up with the sine of a negative pi over 3. So that means is that we're going to have to do this little trig ratio guy right here. All students take calculus, and our reference angle is going to be pi over 3. So we know that the sine of pi over 3 is going to be, let's see, root 3 over 2. However, it's parked in cosineville, which means is that that result is going to be negative, okay, because it only cosine is positive right there. And so that brings us to the following, is that we get f of 0 equals 1.5 times the negative root 3 over 2, which is going to be approximately, okay, it looks like it's going to be about negative 1.3 here. So we got negative 1.3. Let's check to see, is that reasonable according to our graph? Well, it looks like it is, because there's a negative 1 point something, and it looks like a 0.3, so we know that we're not too far off. So we got 0, comma, negative 1.3, and some change here, okay? All right, so moving on to the very last part, which is the domain. And the domain of a sine function, unless it is attached to a scenario here, like a word problem, is going to be negative infinity to a positive infinity. You can plug anything you want into it. However, the range is going to be from there to there, which basically means is that its lowest valley to its highest peak. So, and including those, so that's going to give us a negative 1.5, comma, 1.5, and include those. And, yeah, that's going to finish things off. So, that's how we put all the pieces together. And I got another example coming up for you, so hang tight.